Hey, so new video, once again inspired by the ImageSC forum. Um, so there's been a few questions the last few months over which basically are about uh, semantic segmentation. So basically, people want to segment like a vessel-like or root-like structure. And what you're looking at here is a collection of plant roots. So sometimes it's cracks, sometimes it's vessels, sometimes it's roots. A few questions, and it's one question that um, over the last few months nobody's really provided great solutions. So I think there's a couple of, like if you're interested in semantic segmentation, uh, and that's segmentation when you're dividing, classifying an image into background pixels and one or more foreground classes. A couple good places to look are Zero Cost for DL. They have some good examples of everything, including semantic segmentation. And if you go through Digital Srini's collection, there's some good examples in here. What I'm going to do today is show how to use Napari with some extra widgets and PyTorch to do semantic segmentation. So first off, the code for this problem is available in my little utility library, TNI Python. I have a notebooks section, and for questions I answer on ImageSC, I have them all organized by date. And this one I just call plant roots. It's one of the newest ones. The data. So if you get the code, it's organized into different notebooks. The first notebook gives you links to some of the questions that inspired this problem and some of the data. And the data that I'm going to use, again, it's plant roots. And you can also find it, first off, I put the subsection I used on Dropbox. Then you can find the complete data set on Zenoda, and it's part of the Root Painter project. And if you're interested in roots, I highly recommend this toolkit, Root Painter. Even if you're not interested in roots, it's a good resource. The paper was really interesting and learned a lot about semantic segmentation, deep learning, and also had a lot of good hints for the augmentation. And then another thing I use in this example is a sort of a GUI widget that I'm developing called Napari Easy Augment Batch DL. It's in the very, very early stages. And the idea behind this is over the last year or so, I've been doing a lot of notebooks for deep learning. And I'm starting to think about, okay, how can I get some of that functionality behind a GUI? Very early stages, not ready for prime time. I'm only going to use a small subset of the functionality in this example today. Okay, so if you end up getting this code, you'll see, again, organized into sections. This second one is called 10, is the dependencies you need to install to get this working. And oh yeah, and just sometimes people are confused, well, why is it named 5, 10, and so on? Why not start with 1? That's done a lot of times just because, like, if you have a collection of these and you ever realize, oh, I need an extra one between 5 and 10, it leaves room to, like, add things you forgot about. So this is a common naming numbering scheme where you skip a lot. So let's take a look at our data. Again, it's roots, but really this is aimed at any vessel-like structure, crack-like structure, root-like structure. And the first thing we do here is just put all the images we're working with in a directory, and then this first notebook, it's going to start up Napari, and it's going to add this extra widget and point the widget to our directory of images. So let's run these cells. Okay, so you see here I've got Napari, I've got a little a few little GUI controls. I've got it's loaded the directory of images I pointed to as a series, so I can sort of scroll through it. And I've got several different layers here: images, labels, predictions, label boxes, and then these last two are actually bounding boxes that you'd use for YOLO, but we're not going to do YOLO in this problem, so we won't worry about that today. What we do have to think about are label boxes, which are boxes that indicate which regions we want to label. Predictions, we'll look at some predictions once we train a model, but no model yet, so no predictions yet. And then labels, we have no labels yet, we have to create them. And if you look in the directory where your images were, it's all sort of created some corresponding folders to store like the information related to these Napari layers. And really, the information in this folder isn't Napari specific. This is like, I don't know, if you're doing like, if you ever heard of MVC, Model View Controller, Napari is like your view, you're viewing your data, but then the model can be independent of Napari. So actually, this data here could be, you could hook up some other GUI to it. Or you could just process it with notebooks. And actually, that's what I have been doing for the last year. All this organization, I've been doing pretty much the same thing in notebooks for more than a year. But now I'm experimenting with integrating Napari more with these deep learning workflows. Okay, so what do we do here? We sort of go through our image and we look for maybe an interesting area to label. So I'm going to, let's see here. I'm going to maybe try this one here. So what I do is I get I choose the label box layer, draw a box, and then I have to label everything inside the box. And Napari is really good for labeling. It has a lot of great labeling tools. And the zoom and the pan and everything is great to sort of guide you as you're labeling. We use the paintbrush here. Control the brush size to be about the same size as the structure we want to label. And then we start labeling. Okay, so I'm going to turn the video off for a bit because you don't want to watch me label for 10 minutes. Okay, so when I stopped the video, I labeled one area with really thin roots. And let's see here, I labeled, where is it? Another area with some thicker roots. And now that I'm sort of going through these images, maybe I'll see if I can find one more area with really thick roots. Let's see what we got here. Okay, maybe this guy here. This will probably be easy to do. I am going to, once again, I grab the label box and I circle or draw a region around this, and then I can use the painting tools to color these guys in, and I can make the brush really big for this one here. And yeah, and Napari just makes this really easy. And the purpose here isn't to get like the best labels ever, because I'm really just experimenting, doing a video, showing how to do something, also testing some of my widgets. And if I was going to do this for like to come up with a network, a neural net trained a model I wanted to use long term, I would take much more care doing the labels. Like maybe you'd spend even like days or a couple weeks doing it. So yeah, so these ones I'm mostly just testing the wiring, and this one was probably a little too thin, so let me make this guy a little thicker. And one more to do. Maybe I'll just pause it for a second here. Okay, so I got some of these guys. Some of them might have been really faint, so I'm not totally sure if they're really roots or not. So you know what? You can go back and do some erasing too. Man, maybe that is a root. Okay, I'm no expert in roots, so I don't know for sure if I did this right, but we'll see what we get. And then so we have to hit save here. We save the results. Okay, and then so we drew some labels. If we go back to our project here, we look in the label directory. um, input, and we can see, oh yeah, they're there. So yeah. So how do we train a neural network with just 3 labels? How do we expect to get good results? Well, we use augmentation. This second one of these other notebooks, number 20, it augments. So we make a bunch of patches from the labels. So augmentation is like applying transformations, intensity transformations, rescaling, rotating, reflection. So you create many patches from each label. So yeah, so when we hit, after we apply the augmentation, we now have tons of little patches to train on. And I think we've actually, this might be a little overkill actually, we've got like almost 2,500 patches, some of them quite colorful, most of them not colorful because color isn't a big deal for this problem, as far as I can see. But just to make the network a little more robust, we did do some color ones. Mostly rotation, reflection, intensity based transformations. Okay, so now that we have artificially created a lot of data. Oh, one quick thing I should mention is that a lot of times this augmentation, it's sort of hidden from you. So in a lot of neural network systems, it's done sort of lazily. So it's actually done on the fly. I prefer to actually at least sometimes actually write the patches to disk and take a look at them just so I can diagnose if anything goes wrong, I can diagnose problems, and then I could also reuse the patches for like multiple different network types. So to keep so if I want to compare like CellPose and Stardist, I could keep the augmentation constant and just test like the different network architectures instead of if the augmentation is built in, you're kind of testing like the augmentation too. Okay, so now that we have all these patches, we can train. So we've got this next network here. We'll actually use PyTorch, set up a PyTorch model, and I don't have time at all on this video to really do PyTorch justice. But again, this code is all on GitHub, so you can take a look at it. And yeah, so basically we're going to set up a PyTorch neural network, and I'm going to pause while I actually do the training. Okay, so yeah, so the neural network is training right now. It's 2,000 patches, so each epoch has a lot of data to look at. So this is actually not going to take too long on a good GPU. So we'll see what we get. We'll probably do I don't know. It's actually only going to be a few minutes of training. Again, we don't want to watch it all in video, so I'll pause and show the results when I come back. Okay, so the training is finished. It actually wasn't. So I trained this for 3 minutes, 52 seconds on my gaming GPU. So what kind of neural network can we get in less than 5 minutes? Well, let's take a look. Okay, I've started Napari back up again, and this time we have a model. So again, here's my project I've been working with. You see there's this models directory, and there's a little model in it. That's the PyTorch model we just trained in less than 5 minutes. So now now that there's a model, the predict should do something. And there we go. That is our result. And that was the result of training for like 5 minutes with only 3 labels. So what's kind of cool about this is that what's inside the bounding boxes is what we labeled, and what's outside is what we didn't label. Let's look at this next one. It's actually not too bad. I mean, I'm sure it's going to fail in some places, but not too bad at all for 5 minutes of training and 3 labels. I mean, the augmentation obviously helped. I think this video is going to cut short, but I will talk more about how to improve the model maybe in a subsequent video, but I think this is this is pretty cool for a minimal amount of work.